All right, a box is being pushed across the table with 24 newtons of force. The mass of the box is 15 kilograms. Let's say it's accelerating 1.2 meters per second squared. We want to find out what the force of friction is on the box. So yeah, go ahead and pause the clip and set up your free body diagram, some of the forces in the X and Y, and see if you can determine the force of friction on this box. And then, yeah, so pause the clip, and then when you're ready to check, you can hit play to continue. All right, so we should have force apply going forward, force of friction back, normal force, force of gravity. And if it's going across the table, the normal force, force of gravity are balanced. We have the positive force applied plus negative force of friction equals ma. And we'll, subtract that to the other side. Friction will be 6 newtons. So 6 newtons is the force of friction holding this back. Otherwise, it would accelerate more if you had, less friction. Okay, so for the same problem, after 7 seconds, what's the displacement of the cart? And let's assume that it's starting from rest. And so go ahead and pause the clip and see if you can get that. And then when you're ready to check, you can hit play to continue. Okay, so we have our force and, 6 newtons there. I don't know why I have 4. But yeah, 6 newtons is the force of friction, and we have the acceleration, which is 1.2, which we've already gotten, and we know how much time. So it'll be going 8.4, and the displacement of the box will be 29.4 meters. That's how far it will be going. After it, we have that force. And so, as we look at force and we look at the the interaction with that and acceleration, we can solve for acceleration. Then we can, use the constant accelerations to solve for, what we're looking for there. All right, so for this one, go ahead and determine the net force of this system. If we have a 20 Newton force going up, 40 Newton one going to the right, and 5 Newton down, go ahead and get the net force on the system. Okay. So we have our total y, our total x, and therefore we can set up our coordinate axis 40 to the right, 15 up. And we get Pythagorean theorem, 42.72 newtons is the hypotenuse. Opposite over adjacent, we can get the angle. So the overall force is 42.72 newtons, 20.6 degrees north of east.
So in this problem, we have the relative velocity. We have an airplane pointed north with the velocity 63 meters per second. Wind is coming from the west at 15, and we want to find the relative velocity of the airplane to the ground. So just like we did with vector addition before, we have 2 velocity vectors, and we want to get the resultant. So the very first thing we want to do is draw our coordinate axis, and then draw our velocity vectors. We have the airplane pointed north with velocity 63. Wind is coming from the east to west at 15. And we want to find the relative velocity. So go ahead and pause the clip and calculate the resultant velocity with the, you'll get blank meters per second, blank degrees, blank, blank. So go ahead and pause the clip and give that a try. When you're ready to check, you can hit play to continue. All right, so we get a resultant, and our hypotenuse is 64.16. And opposite of adjacent, we can get the angle there, 13.392. And this would be east of north, because we start on north and go east.